Hello, everyone. Welcome back to your Azure Cloud Series. In today's episode, we are diving into the core Azure architecture, its global infrastructure, some key components, and how it ensures high availability and fault tolerance. So let's get started. Let's start with the overview of Azure's global infrastructure. Well, Azure's infrastructure is designed to actually deliver services globally while maintaining high performance, scalability, and resilience. It's built on three main elements: regions, availability zones, and data centers. Let's start with regions. Well, Azure operates in over more than 60 plus regions worldwide, allowing organizations to actually deploy services as close as possible to their customers or users. This setup actually minimizes the latency and ensure compliance with local regulations. Now, this compliance might be coming from the industry or the government, it doesn't matter. But cloud platform make sure that there is a way to be compliant. Now let's go back to region. Each region functions independently, providing a localized access and disaster recovery option. So that is your region. Now, what are availability zones then? Well, within each region, multiple availability zones, or you can call them AZs, are available. These are the physically separated data centers equipped with independent power supplies, cooling loop, and networking. By distributing workloads across these zones, Azure ensured that even if one zone experiences an outage, services still remain available in other zones. So remember, one region can have multiple zones inside it. Now, it will all make sense when we'll discuss what are data centers. Well, at the core of Azure's infrastructure are its data centers. Millions of square feet of secure, high-performing facilities connected with high-speed fiber networks or fiber channels. These data centers actually house servers, storage systems, and networking equipments that supports Azure's vast array of cloud services. So the hierarchy is region, then multiple zone. In the zone, you have your data centers. Now, Azure's global reach actually spans continents, including Africa, Asia, Europe, North America, and beyond. This widespread presence ensures that the users worldwide can access cloud services with very low latency, as low as possible, while built-in redundancy and DR, that is disaster recovery capabilities, provide added fault tolerance, or you can say resilience. Now let's talk about some key components of Azure architecture. Remember, some of the logics or some of the points will be repeated. That will be a recap for you. So Azure's architecture is composed of several key components that work together to deliver reliable and scalable cloud services. So let's break them down. The first one is data center or data centers. These facilities form the backbone of Azure, hosting the physical infrastructure needed to run your cloud services or the services which you are using. These are designed for scalability, fault tolerance, and high security. Azure data centers can support wide range of workloads, Whether you want to deploy your websites or app services or virtual machine, all the services are possible due to data centers. They are running your services. The next component is server or servers. Both your virtual machine instances or physical services are available to meet different compute requirements. VMs provide flexible and scalable compute resources, while physical servers support high-performance tasks that require dedicated hardware. Both are available via Azure. The next core component is networking. Well, Azure VNets, or you can say Azure Virtual Network, it actually enables secure communication between resources, whether they're within the Azure ecosystem or even connected to some other cloud platforms. And one more point, your resources can also be on premises. With networking, they all can talk, they all can communicate. One more point. How about load balancers? Well, load balancers are also used by Azure Cloud Platform. I'm not just talking about a load balancer which you create for your usage. No, not just that instance. Even Azure use load balancer methodologies or technologies in their data centers. So what are load balancer? Well, these systems distribute traffic across your virtual machine instances, ensuring optimal performance and high availability. So they also use that. The next is ExpressRoute. Well, ExpressRoute provides a dedicated private connection between on-premises network and Azure, offering greater reliability and security compared to your public internet or public domain. The next component is storage. Azure offers scalable storage solutions for data backups and applications. Examples include Azure Blob Storage for unstructured data and Azure Disk Storage for persistent VM storage. I'm talking about the disk which your virtual machine use to store operating system. You can also call it OS disk. The next core component is identity and security. Well, this is actually managed through Azure Entra ID. Used to be called Azure Active Directory. Remember, the name is changed, but the functionality is still the same. Azure Entra ID. So in the future episode, if I say Azure Active Directory, please remember I'm talking about Entra ID. But I will make sure to call it Entra. Now, Azure's identity and access management services ensure secure authentication and authorization across all the cloud services or resources. This is actually very important. Now, how Azure ensures high availability and fault tolerance? Well, Azure's architecture is built with high availability and fault tolerance in mind, ensuring that services remain operational even if there is an event of a failure or maybe a natural disaster or maybe a man-made event. The key features include multiple availability zones. They spend a lot of money for that. Now, by deploying resources across different availability zones, organizations can isolate faults and prevent outages from impacting their business continuity. The next logic is load balancers. Well, Azure Load Balancer distribute traffic across multiple VMs, preventing any single instance from becoming overwhelmed or crash. This way, you can rest assured that your service will be available even though few of the machines are down, because your load is distributed across multiple machines in the pool. The next concept is automatic failover. Well, critical services like your web or website virtual machine or web server or databases can automatically fail over to the healthy instances in the event of any outage. The next one is geo-replication. Well, here the data is replicated across geographically separated regions, not in just one region. This ensures that it remains accessible even if the whole region experiences some kind of a major disruption. The next is the promise, that is SLA, Service Level Agreement. Azure offers SLAs with uptime guarantees of up to 99.9% and sometimes 99.99%, providing a peace of mind that services will remain available. Now, let's summarize everything. To sum up, Azure Global Infrastructure uh, is made up of multiple components. Some of the key components are region, availability zones, data centers. They all offer robust fault tolerance. Now, they also offer reliable operations, scalability, and security within the core. By leveraging regions, availability zones, and advanced networking, Azure also delivers high performance with minimal downtime. So now you know the building blocks of the whole Azure cloud infrastructure. So stay tuned for further episodes where we will dive deep into multiple services offered by Azure. Until then, happy cloud computing.